Hi folks, this is the next video for the Further Maths GCSE. The last lesson on circles. Now, this is the equation of a circle, but it's not particularly useful to us because remember, we want it to look like x minus a plus y minus b, sorry, x minus a squared plus y minus b squared equals r squared. Well, it doesn't at the moment. I can do it by completing a square. And I've got to complete the square for the x terms and the y terms separately. Any constants, by which I mean just numbers, I would just leave and put together at the end. So, as a reminder, completing the square, half the coefficient of x. No numbers on the end, but of course if I expanded this out I'd get x squared minus 2x add 1. Well, let's get rid of the 1. Excuse the dogs in the background. Same deal here, half the coefficient of y. That would give me y squared minus 6y add 9. Well, let's get rid of the 9. And then I can just add 10 onto both sides, and it looks like the form that I want. And I can see that the circle has a centre at 1, 3, and the radius root 10. Okay, so let's go through the PowerPoint, look at some example questions so you can have a go at the exercise. I'll get rid of that. There you go. Okay, so have a read of this. You're going to have to be doing a lot of pausing, by the way, but that's okay. Complete the square. Don't get fooled into thinking that 9 is a y term, because it's not. So complete the square, find coordinates of the centre, find the radius. Find out where it crosses the x-axis, and of course that's where y equals 0, and it's points, so I'm expecting a quadratic. Okay, now's the time to pause it now. There's your answers. So, just a little practice for you. Completing the square, finding the centre and the radius of each of those. I'm going to expose the answers, uncover, whatever. Time to pause now. So here come your answers. Oops, there you go. Okay. Some circle theorem just to remind you about. The first two are GCSE, the third one is not. Radius and a tangent are perpendicular. I mean, you may not have seen these yet, but that's fine. Angles in a semicircle are all right angles. And the new one, the perpendicular bisector of a chord, let me say that again, perpendicular, i.e. 90 degrees, bisector, i.e. goes through the midpoint, of a chord, perpendicular bisector of a chord, also goes through the centre of a circle. So generally, given 2 points of the chord, find out its gradient, therefore find out the perpendicular gradient, find out the midpoint of the chord, therefore find out the equation of the radius, and given one of the ordinates, I can then find the other. We're going to look at a couple of examples of that. I mean, somehow demonstrate the fact that you know this is a right angle. These can be quite varied. And generally these are, I'm given the circle, I have to find, or I know the centre, I know the point, so I can find the gradient of the radius, which means I know the gradient of the tangent because it's perpendicular. And given the point, I can do y equals mx plus c and find the equation of the tangent. And we're going to look at one of those. So just before we do, a bit of practice at you finding perpendicular gradients. Time to pause now. Here are your answers. Now the last one I haven't exposed yet. I would use y equals mx plus c, but there is a different form of the equation. We don't tend to teach it at GCSE, and I actually don't use it really at all at A level. I always use y equals mx plus c, but this is another form that you may wish to use. I don't think it's any different to y equals mx plus c personally. Okay, this is what I was talking about. So do this then. Have a go. Find the gradient of the radius. Use that to find the perpendicular gradient of the tangent. I've got a value of x and y, so I should be able to find the equation of the tangent. Remember, it's going to be y equals mx plus c. So the gradient of the tangent is my m. I've got a point x and y, so I can find c. Time to pause now. There's your answer, y equals minus 2x at 10. Okay, I'm going to show you my diagram in a second. Now, you do want to draw a diagram for this sort of thing. So, if you don't want to see my diagram, then pause it now. There you go, there's my diagram. So I've got my 2 points. What I want to do is find the gradient of that chord, find the midpoint of that chord. If I've got the gradient of the chord, the perpendicular is the gradient of the radius, and if I've got x and y at the midpoint, I can sub those in to find the gradient of the equation of the radius, and then given the x ordinate, find the y ordinate. Now you might want me to say that again, so rewind and have another listen. I'm going to show you the answer in a few seconds, so have a go at the question if you haven't yet. Pause it now. There you go, there's your answer. There's the y ordinate of the answer. Now, he's used a different formula. Yeah, I would use y equals mx plus c, but that's fine. That also works, of course. Okay, show that OP is a tangent. Well, I've got the circle. So work out the gradient of CP, work out the gradient of OP. Show that one is the negative reciprocal of the other. Also work out the distance OP using Pythagoras. Show that it's the same as the radius of the circle. Have a go. Pause it now. There you go. There's your working for part A. The second question is essentially the same as the last question we did on the last slide, so you might want to rewind, look at my diagram if you're not sure, but I'm not going to show you the diagram for this one. I'm just going to give you the answer, so have a go at it. Pause the video now. There you go. So there's the y ordinate. Okay, I'm going to upload exercise 3, so you don't need to work from the screen.